Welcome to Signals, the podcast where we step back from the hype to look at what's shaping technology. In each episode, we talk with industry experts to surface trends, question assumptions, and unpack why things work the way they do today. We're focused not just on what's new, but on the decisions and developments that got us here and what to expect down the road. I'm your host, Michael Dowden, and here with me today is Abdel. Thank you so much for being here. I think we've known each other for a while now. We met first in Morocco in 2019, I believe.
Yes. Been a while.
So tell me what you've been working on.
Yeah. So hi everyone, it's Abdel. I'm a developer advocate at Google. I've been working on Kubernetes for quite a while. I think I can consider myself a subject matter expert now.
Yes.
Mostly, started working on Kubernetes about 8 or 9 years ago as a consultant because we have quite a lot of users on our platform using Kubernetes as a tool. And then over the last 3 years, I transitioned to an advocacy role where I am talking to people about how they actually should use Kubernetes more. So
yeah. So when you search for Kubernetes information, your name does tend to pop up from time to time.
I guess I know why.
So tell me a little bit about what is the state of Kubernetes today? Is this something that you think all developers should be in and using if you're in the cloud? Is it something that you think is only for specific people to be working with? Where are we today?
Yeah, it's a very good question actually. I will take you a little bit down the kind of history line, and during this history line, we're also going to talk a little bit about DevOps and the evolution of DevOps because I think they kind of go hand in hand together.
For sure.
But Kubernetes is 11 years old, right? So 2014 was the first time when Google open source Kubernetes. And the project now has 11, 12 years. It's pretty mature. Adoption is through the roof. A lot of companies have it. Most major cloud providers have some sort of offering around Kubernetes. Today, I was just looking into some internal stuff just on Google Cloud. About 100 products on Google Cloud uses Kubernetes actually under the hood that people don't even see, right? And this question of is this a developer tool have been kind of a point of contention over the last couple of years, and people have been going back and forth because there is a love-hate relationship. And there is a very simple reason. Kubernetes is an API-driven system. So as a developer, you are kind of pulled toward anything that has an API, right? But it is still infrastructure. Which most developers don't like, right? So it's a way to drive infrastructure using an API. So compared to having to do infrastructure yourself with bash scripts, I think Kubernetes is probably a way better way of doing it. But it is still infrastructure, and you have to understand the IP addresses, firewall rules, network policies, all this stuff that most developers don't and frankly shouldn't have to care about. And I think at the same time, there was this evolution of DevOps, right? DevOps have been around for a while. People have been talking about it. And they sort of went hand in hand in the sense that if you are a developer just building backend or front-end code and you work in an organization that have a DevOps team, for the most, you don't have to care about Kubernetes. It's just there. It just works, right? You have a CI/CD pipeline, push code, get built, get deployed. You can check out your code in production and then move on with your life, right? But then there is this new kind of evolution in the DevOps space called platform engineering, which is sort of like the next generation way of looking at DevOps. And instead of considering more like, is this a role? Is this an engineering practice? Considering everything that the developer have to run on as a platform. And whoever takes care of the platform is called the platform engineer, right? And so in that space, I think that there is still this clear line where developers for the most shouldn't really care about Kubernetes. They should just assume, I'm putting assume in quotes here, in the sense that it doesn't have to be there, but if it's there, it should just be transparent, right?
Right.
And the most important thing I think that platform engineering as a practice brought into the table is this entire concept of IDP, internal development platform, where if you are doing platform engineering right, what you are supposed to be doing is give your developers a platform that they can just shop in through a portal. So they can go in and they can say, give me a database, give me this, give me that, give me this, give me a place to run my app. I don't really care if it's Kubernetes or not, right? The State of Platform Engineering report, which came up in 2025, about 60% of companies that adopt platform engineering as a concept actually have Kubernetes under the hood, right?
That makes sense.
And what an IDP does really is that it gives the developers that much higher level if you think of Kubernetes as an abstraction layer over infrastructure, an IDP is an abstraction layer one level above, where it gives you the Kubernetes infrastructure and then everything else your app needs, right? Because your app doesn't live in a vacuum. It needs a database, it needs certificates, it needs authentication, stuff like that.
Yeah.
So I think there's a long way to say, for the most, you shouldn't, unless you have a very particular case or a very particular use case, which is you are developing products that are tangibly or that are tightly related to Kubernetes itself. Unless you are in these kind of situations, for the most, it shouldn't matter for you as a developer.
So it has a lot to do with how the type of product you're building and how you've architected your product and how you intend to roll it out to your customers, I would imagine. So if it's something where you're wanting to spin up infrastructure dynamically in real time as you onboard customers, then it might be something that's integrated directly API level into the way you build an application, for example. Would that seem reasonable? Okay.
Yeah. I mean, I can give you a very good example here. We have a lot of customers that are building tooling for developers, right? So they're building things that developers use. I mean, the example that comes to mind is there's a lot of companies today that are building backend system for running Flutter code. So Firebase like platform. So not Firebase, but something that's like Firebase. So what you are building effectively is something that is targeting developers. So you will have to deal with infrastructure anyway. And for them, Kubernetes gives them that API so they can provision the infrastructure without having to care about the underlying virtual machine. But then for their developers or for their users, they shouldn't really care, right? I have Flutter code, I just run a command line, it just gets pushed to the cloud, and they shouldn't care, right?
Okay. Yeah, that makes a lot of sense. So how do tangential technologies like GKE, Anthos, Service Mesh, stuff like that, how do those interrelate with how you work with Kubernetes?
Yeah, I mean, GKE is just the product. It's a Google Kubernetes engine. We are not the only one who has this. EKS has Elastic Kubernetes engine. Azure has Azure Kubernetes engine. It's basically managed Kubernetes, right? So like the same way you get a managed database or a managed PubSub system, it's a managed Kubernetes. So we manage the entire thing for you. You get an API, which is the standard Kubernetes API, and then you talk to it using kubectl, which is the command line for Kubernetes. So that's like the most basic thing. Anthos technically doesn't exist anymore in the sense that we started with it and we retired it, we changed the name. But what Anthos really is, or what we call now GDC, Google Disconnected Cloud or Google Distributed Cloud, I don't really remember what it means, is it's basically a packaged Kubernetes that you can run on-premise, right? You can think about it, I think you have been in the industry long enough to remember, there was a time when we talked about Linux as an operating system, and then we talked about Ubuntu as a distribution. So Ubuntu is just like an opinionated version of Linux. So you can think of GDC as an opinionated version of Kubernetes. So Kubernetes is the open source thing, and then you get like a package version that you can run on premise. And that's something that, if we take all the developers in the world and we say that maybe 10% of them will have to deal with Kubernetes, then maybe 1% of the 10% will have to ever talk about what GDC is, right? And Service Mesh, on another hand, that's actually a very interesting that's a very interesting piece of technology that I think has a future. It's been a little bit slow to adopt because it solves problems at the infrastructure levels that most people, again, shouldn't care about, right? What really it does, it solves the problem of how can you add intelligence to the network layer. Like I can give you a very simple example. So let's say, for example, you are rolling out a new version of your app. You have the standard, regular, rollout strategies, blue, green, canary, whatever you want to do, right? And for most of the time, these are pretty complex to do, right? Like you have to set up some sort of proxy to be able to, route part of the traffic to the new version, monitor the new version. And so what really Service Mesh as a concept have been introduced to do is to solve this kind of problems, but using configuration. So instead of having to deal with the underlying infrastructure, we're just configuring in YAML format the mesh, which is the network layer, to be able to do these things on our behalf. Canary deployment, blue, green, blah, blah. And so Service Mesh, I think the first tool that was introduced was Istio about like 7 or 8 years ago. That also came from something that Google was doing. We've been doing for a very long time. So we just took the same concept and we built something that looks like Istio. And in a very funny coincidence, it followed the same history of Kubernetes. So Kubernetes was initially released to manage Docker containers.
Yep.
So Istio was initially released to manage Envoy, which is a proxy, which Envoy was built with the Lyft independently from the service mesh itself. Somebody at
Right.
Lyft was building it, and they were like, they had no idea that this thing called service mesh existed until we open sourced it, right? And so it is really a layer on top of Kubernetes. You can install it on vanilla Kubernetes, manage Kubernetes, or on GDC or Anthos or whatever. And again, for the most, as a developer, you're probably not going to have to deal with it. If it's part of your platform, then it should be available for you in the IDP, where you just click a button and you get Canary. But it's something that probably your security team, your network team will have to, install, manage, and deal with for the most.
So if you are a DevOps engineer or platform engineer, how would you say your life has changed over the last few years as a direct result of having Kubernetes compared to, I don't know, older stacks?
Oh, yeah. I mean, clearly going from writing script to writing declarative or to writing configuration, that's like probably the biggest change, right? I think if you've been doing, the old version of DevOps engineers, which I think we can call system administration, right?
Right.
You've had to deal with Bash, maybe Python, script your way around it. Then there was a little bit, at some point, the new tools started emerging, things like Chef and Puppet, which kind of achieved the same thing, but in a more server client configuration or architecture. And then Kubernetes came to the picture alongside Terraform, which is around the same time, which essentially went from a prescriptive programming language to a declarative programming language, right? Like instead of you prescriptively telling the platform what to do, you're just declaring your desired state. So that's been probably the biggest shift for DevOps engineers in general, right? And then the other probably, I think that for most DevOps engineers that have started working a few years ago, most of them have started working in the cloud. So for the most, for most of them, they probably don't even know that before firewalls were distributed, they were just a box in a data center, right? Or before load balancers were software driven, they were like an actual physical box in a rack somewhere, right?
I remember those.
Yeah, there you go. And so that's probably is not a shift that many have experienced, but what actually I think is going to happen going forward is like the reverse shift, because there is a huge now, and that's a huge, there is like a trend in going back on premise, and people now have to go back to deal with like physical boxes and physical hardware, physical infrastructure. And so, but I would say like, yeah, the biggest shift is the shift in the way you do things. So programming to configuration driven things. And also maybe the shift in the mentality of like splitting responsibilities, kind of layering your stack and being responsible for a layer that somebody else depends on. And yeah, I mean, and I guess now, I mean, we cannot avoid it. Like AI is just like impacting everyone in many ways that than people want to admit or are comfortable with. But yeah, I mean, it's changing all the time. But that's just like how the industry is, right? So
yeah, absolutely. So would you say that the shift off of the cloud is the biggest thing that's happening right now in this space, or is there something else that you see as kind of the next big shift?
So you mean off the cloud back to on-premise?
Yeah.
I mean, it is a trend that we are seeing, right? I guess probably the loudest voice on this space would be DHH, the Signal 37, going from AWS back to on-premise. There are so many things to say about that particular. It is a great lesson, right? So whether you agree with what DHH writes and you agree with everything that, like all the conclusions, or you kind of have a little bit of, let's say, a pragmatic look at things, and you can like look at it from the perspective of like, when you started going to cloud, somebody should have pointed that this is the wrong approach in the first place, right? So, but that's that's a discussion for another time. But I think that the point is, yes, there is a trend of shifting back to on-premise, but there is actually a very interesting thing that I am learning over time, is that like when we say a shift back to on-premise, we're really giving it the wrong term, in the sense that to a lot of people like me, it might sound like, oh, I'm moving off the cloud back to my own servers. But in reality, what's happening, I think, is I am moving off the cloud to a managed server farm. So I'm still getting managed infrastructure somewhere. I'm just not getting the cloud version. I'm getting a server that I pay for, but I am not renting the rack. I am not renting the data center space. I just pay somebody, and then they install the racks for me, and they give me the servers, and I don't have to even physically touch them, right? And so it's sort of like, I guess if we go back to the old school classification of like PaaS, EaaS, SaaS, I think we're going back to like a PaaS kind of like a platform as a service kind of situation. Yeah, and this is clearly something that is noticeable. One of the biggest signals is like all the cloud providers today are interested in giving you a piece of software to run on premise, because they are seeing that trend, and there is like there is business to be made there, right? So that's one of them. And then I think that I'm gonna shift a little bit toward the future, the future part of your question. I think in the future, what we're gonna see more is if we continue going toward those AI models that everybody wants to run now, being either A, too expensive, or B, too hard to obtain the hardware you need to run on, then we are probably going to go to a situation where people will just want to buy the hardware and do it themselves, right? Or for privacy reasons, or for sovereignty reasons, or all the reasons that people want to run on-prem. So I think that this shift is continuing to exist, or will continue to exist. Whether it will accelerate or not, that remains to be seen.
Yeah, that makes sense. So for those who remain cloud native, is there a next step beyond some of the Kubernetes? And is it, obviously I've been working in the serverless space for quite a while, and serverless benefits a lot from Kubernetes. I don't have to touch Kubernetes. I don't have to worry about it, but that's how realistically I believe a lot of the providers are making serverless options available to us, right? And so I don't have to, in the serverless space, I don't have to worry about, DevOps is very, very light in that world. Is that the future, or is there something even a step beyond that in where we're going on the cloud platforms?
Yeah, I mean, I think that there is space for serverless to remain and maybe grow over time, just because there will be more and more people who just build apps and want to run them, and they don't want to do DevOps, right? Serverless is a great way to. I mean, I am the biggest fan of Kubernetes. I would be the one to say start with serverless. Like, you don't have to start with Kubernetes, and then if you get mature enough where you need Kubernetes, then maybe you can start thinking about it, right? What I think, one of the pieces of technology that I'm actually keeping an eye on is it comes in multiple names. I call it edge workers. So that's essentially being able to run some sort of lightweight code closer to the user. So that would be things like Cloudflare Workers, for example, which is essentially a serverless platform, except that it doesn't run in data centers. It runs on a node closer to the user, right? So you can do pre-processing, or maybe all the processing you need. If the processing is very lightweight, then it's great. I was watching an episode of I think Theo T3GG, like a very popular YouTuber who has this platform called T3 Chat, which is a wrapper around multiple AIs that allows you to talk to multiple AIs with like single subscription. And he was talking about how they moved off Next.js to, I don't remember the name of the framework they're running on right now, but they have been moving toward this new framework. And then in the process of moving, they've been relying a lot on edge workers to deliver, the JavaScript assets bundles to the user much faster, right? And then to do pre-processing at the edge. And I think that's going to continue growing. That portion of the market will continue growing, right?
Yeah.
So that's for sure, for one. Serverless clearly is going to continue growing. I mean, I think that the biggest indication why this is going to continue growing is that there is now interest from big cloud providers to providing you with accelerators on top of serverless platforms. Cloud Run has L4 GPUs. There will be more type of GPUs coming. That's because, as developers, I want to run a lightweight LLM or an LLM in general on my serverless platform. I don't want to be strong-handed to go down to the Kubernetes world. I just want to continue working in my space. And I think that there is also this other portion of the industry, which probably we don't talk about that much, or I don't see that much, is edge workers, but not in the context of Cloudflare, more in the context of, I am a big fast food chain that needs to run workloads in the store, right? Like I need to run checkouts and point of sales in the store itself. And I don't want to mention any names, but like insert fast food chain and think about it as you walk into your favorite fast food chain and then you talk to a kiosk machine, you make your order. That machine is not talking to a backend running in the cloud. It's probably talking to a server running in the same store where you are, right?
Right.
And there is a very popular American fast food chain that started doing this and started blogging about it. And over the time, that caught the attention of a lot of providers. And now there is actually more offering in that space as well.
That makes sense.
Yeah.
So with the kind of trend to some companies doing more on-prem, whether that's because they want the privacy or the control, or because like the fast food situation, you need maybe a server a little bit closer to the actual point where the user's interfacing with it. This feels like it's a little bit of a pendulum shift, right? Like we get these pendulum swings in the industry where everything's as close to the user as possible and everything's out in the cloud, and we get these swings back and forth. This feels like another one of those pendulum swings to me. Would you say that's correct? Is this what does the next swing look like once we get through this? Like what are some of the reasons you might see somebody making choices for the future? Like what are the decision points that you see people making?
Yeah, I really like this analogy of pendulum because I think that the future will be that pendulum eventually will have to find equilibrium at some point and stabilize, right?
Right.
And in the process of this stabilization happening, I think what's going to happen is we're going to get to the point where we realize as an industry which workloads run best closer to the user and which ones run best closer to the data center, right?
Right.
And which one runs in between, right? And it's not like it might sound to the audience that the way we're describing it is kind of extreme. It's binary. Either you're closer to the user or you're closer to the data center, but that's not the case today because you're like in between, right? I mean, the best example I can give you is when you watch YouTube, you're not streaming a YouTube video from a data center. You are streaming it from a node closer to you. But that for your the technical term is CDN, content delivery network. But that node doesn't necessarily has to be physically within few miles from you. It can be a few hundred miles from you. It's just that the latency toward that node is much lower than the latency toward a data center in a different country, right? So I think that we are in this process where we are trying to figure out where is the best to run the workload, whether it's, I mean, if we want to go even extreme, whether it's on the actual user device, because that's really as close to the user as you can get,
Absolutely.
right? So in the browser, or all the way back in the data center, or anywhere in between. And I think this pendulum will continue swinging back and forth as new technologies are maturing, as optimizations are being introduced to make things faster, better, cheaper, et cetera. And then at some point, we're gonna get to some sort of equilibrium where we exactly know, depending on the characteristic of the workloads, do we run it actually in one side, do we run it in the other side, do we run it all the way in between? And what I want really to this is just because it's fresh in my head. I just listened to the pragmatic engineer Gregory. I think everybody probably knows him, and he did an episode recently, a podcast episode with the VP of S3 at AWS. And it was an amazing episode, right? And this particular episode, the VP, she went really, really deep into details of how S3 works. And that's like a completely different, like we're talking about like planet scale systems. It's insane, right?
Right.
And I think that there will be, in my opinion, from a pure technical and engineering perspective, more and more need for people to focus on these kind of use cases.
Right.
Because clearly running things in data centers is not enough anymore.
Right,
like we need more capacity, we need more storage, we need more compute. and there will be more and more also focused on running more of this like large scale. Like, 10 years ago, we probably used to say large scale systems is for the big scalers like Google, AWS, Microsoft. I think today, if you are doing large language model, media, whatever you are doing, you are going to be in that situation like in the foreseeable future. You're going to have to design a system that runs at very large scale from scratch, and you need people to do that, right? And so,
Right, exactly.
it's coming for sure.
Right. So I'm really happy. Well, first of all, that's really fascinating. Like the S3 global scale is unbelievable.
Oh yeah, it's insane. Yeah.
I'm really happy you brought up the running on the client device. That's something I've actually been doing for a really long time and am a huge advocate for, because sometimes that's just the best place to do work. So my question to you is, when you look at kind of an industry-wide approach, do you see a future where we have a framework that kind of helps us build an app and deploy it all the way from data centers to the edge to the client device, and the framework kind of helps decide where any given job runs based upon lessons learned over time? Or do you see that as more of a problem that we're going to use AI to solve at the time of development versus in real time as part of a platform or a product?
Yeah. So whether there will be a framework, I don't know, because I'm more like a backend person. So I don't really know much about kind of front end or end device type frameworks that are specifically designed to run, things or workloads on end user devices. What I know is that there is an evolution in the primitive APIs under the hood that enables the types of workloads, right? So,
Right.
the example I can give you, the most recent one, which you probably know, is the Web AI API inside Chrome, right? That's essentially running AI workloads on the browser, right? So that's not a framework per se. That's more a primitive. It's available inside the browser, and then you have to build on top of it, right? So I think if I can put my speculation hat here, I think it would be hard to build a single framework that can figure things out. I think what's most likely to happen is that these AI tools will become more and more intelligent, and with enough training and enough data and enough use cases that they get exposed to, they will be able to help developers figure out what's the best way to do certain implementation, right? Where you can ask the large language model, describe your spec-driven development. You're describing your constraints, or describing your business requirements. Maybe you're describing your latency requirements, technical requirements, and then the model tells you, okay, well, I think for this portion of the application, this would be better. For this other portion of the application, this would be better, etc., etc. So I think that it's one of the things I really like about our industry is that almost everything is built on open standards.
Yeah.
So we're not at the mercy of a single provider to provide us with their framework.
Right.
So I think that's what's going to realistically happen is maybe frameworks will happen that are trying to solve this set of problems, and then some will stick, some will disappear, and as kind of we're progressing and we're learning, we're going to get to a point where either we have a very clear understanding of, depending on the requirements of the workloads, where do we do it, where do we run it? That's one. Or we are having an AI that can tell us this, right? And I don't know if I'm going to a little bit maybe anticipate your next question. I don't know if this is the next question. Like, this actually makes me think that if the future is more about, as an experienced software engineer, do you have the knowledge to be able to make the right decision about these kind of things, right?
Sure.
And I'm going to stop here. Just one last comment. Just if people are actually still wondering what the future looks like, I was in a call today where we're talking about FTP servers. It's 2026. We're still talking about FTP servers. I was on a call with the customer. They are using FTP servers. So, just chill, everyone. It's going to stick around for a while. So
that is a fantastic context, honestly. So I guess that changes my next question, because I want to look backwards just a little bit. If you're not cloud native today, if you're not using Kubernetes, if you're not using LLMs, like what are the alternatives to some of these things that are happening in the cloud native space today?
I mean, there is a huge part of the industry which is, of course, still running on virtual machines, right? Like the virtual machine industry does not just disappear. I will be willing to bet that your again, insert virtualization company here. I think everybody knows who I'm talking about. I don't want to mention the name. I think I will be willing to bet that they are still making big bucks or big parts of their business on virtual machines. They might be wanting to push Kubernetes down the throat of their customers, but like most customers just don't want it or don't understand it or just don't want to hear about it. Or I think you know how it is. Like the biggest I would say the biggest challenge is change. As long as you can convince people to change, that's when you can push technology forward. And if you can't convince people to change, people want to run on things they're familiar with. And virtual machines have been around for a very long time. We know how they work. So why if it ain't broken, don't fix it, right? So so I think the alternative is virtual machines, clearly, right? That's gonna stay around for the foreseeable future, I would say. Large language models, really, you don't need them if you have people who have experience. Experienced engineers don't really need language model. They can just look at the log and tell you what's broken, right? So you and I can look at an error and know it's DNS, right? It's very simple. So I think that there is still a big part of the industry which I don't want to. I think the word that I would use, which I don't know if it's the right word, is immune in a way to these like advancements, because they just don't need them. They are running on systems that already work and already function properly, and they don't even need to know. They don't need cloud native. They don't need DevOps. They don't need Kubernetes. They don't need LLMs. They just like continue doing the thing they're doing. And what's the future for these workloads? I think it depends. I believe that the biggest driver toward innovation for any business, it doesn't matter really what the business is competition. Like the moment when you have an established company doing something and don't wanting to change, not wanting to touch any of their systems, whatever, not wanting to innovate, whatever innovate means, you have a competition, they will be forced to innovate, right? So, so I think people will continue using the stuff they've been using already. So, I mean, So.
There's a company I know of that is still using FTP for files and is using an AS400 as their primary backbone of their organization, right?
And it works, right?
It always is a good, I think, refresher for us as engineers, as architects, platform engineers, to take a step back and look at the whole space that the industry lives in. And as much as we might be super excited about being on the cutting edge, maybe that's not where the company that we're working for is at. Maybe that's not even where they need to be at any given moment in time.
Yeah, clearly. Yeah, I think it's good to, and again, I'm going to go back to that podcast with the AWS person. She used this term that I found very fascinating. It's to be technically fearless, but respect what's there. So clearly she is talking about it in the context of S3, because S3 is a system that, that is supporting thousands and thousands of businesses. And it is clearly not a system that you just want to change, right? Like whatever change you introduce, it has to continue working because there is people relying on it, right? And to your point, for wherever people are working, maybe that's actually the core of the resistance. It's just people are afraid that if we introduce change, things will break. So if you approach it with the empathy and the respect toward what's been there, have been working, and it doesn't rely on you coming with new ideas to suddenly start working better, right? And then maybe also like thinking outside the box, being technically fearless, whatever that means, in the sense that you can just come in and look at a low-hanging fruit, a pain point, something that you can help solve for the department, the industry, the organization, whatever it is. And then at the same time, not really introduce that much change to whatever exists, right? So, I think that's a skill that people have to develop, I would say.
For sure. Okay, so based upon this conversation, what would you say is the number one takeaway you want for the audience today? Like when we look at cloud native, we look at Kubernetes, what's the big takeaway from your perspective?
Yeah. So I will give you two, because I think one will be like more forward looking and one more be more backward looking. I think the backward looking way of looking at things and is to, you have to somehow anchor yourself in the basics of how technology works as an engineer. That's probably the best way you can immune your way, in the sense that like you are building the foundations of how stuff works, right? You know how to code, you know how to design, you know how to architect, all that stuff. Like you know it very well. And then, so that would be the biggest takeaway, right? And then for the way forward, I think that the thing that people have to keep in mind is, except maybe every few 10 to 15 years in our industry, we're not really introducing that much new inventions. We're just building abstractions on top of things that existed.
Right.
Those large language model didn't just happen 3 years ago. They have existed for a very long time, right? I think that the biggest word I would use to describe our industry is the ease of access. What the technology allows us to do is build abstractions that make things easily accessible to people. So to a lot of people, it might sound new, but to people who have been around for a while, it just sounds like, oh, it's just another abstraction layer, right?
Yeah.
And so whether that's Kubernetes, whether that's containers, whether that's service mesh, whether that's AI, it's just like we're just building on top of existing stuff. And as long as you have a very good understanding of the foundation of how things work, anything else that comes after should be easy to understand.
Totally. Yeah, that's a fantastic advice. Thank you.
Awesome. Thank you.
So I noticed that you just launched your YouTube channel last week.
Yes.
So that was a great video. So very, very cool. What is new in your life, and where can people reach out and follow you?
Yeah. Finally, I have a blog. I have my own corner of the internet now.
Nice.
It's abdel.dev. So abdel.dev is my website. And you can find all my social media, all my YouTube. The first video I published on YouTube is a video that came 2 years later after I recorded for the first time. But finally, it's on personal branding for developers. It's kind of niche in the sense that if you're a developer trying to make a name for yourself on the internet, how do you go about it? And it covers things like social media. It covers things like content creation, all this stuff. And otherwise, yeah, LinkedIn, Twitter is where I hang out a lot. And what's coming, I am actually interested in exploring like part of this YouTube channel that I created. I'm planning on exploring it further by creating content talking specifically about foundational technology, like covering things in the foundational level.
Nice.
Explaining basics of stuff. So yeah, hopefully there will be more content coming out there. I'm already working on some cool stuff. And then I will also continue doing interviews because I really enjoy doing those. And I think the other part is the Kubernetes podcast is like we continue to work on with my colleague for Google.
Nice.
So
Yep.
yeah, either my blog or the podcast.
Fantastic. Abdel, thank you so much for being here. I appreciate the conversation as always.
Thank you so much, Michael. Thanks for having me. Bye.